This is the Team Xenon workflow execution demo. The purpose of this demo is to show how a user with access to controlled TopMed studies and controlled GTEx data can log into the FAIR4Cures platform, access the data on the NIH AWS buckets, and execute analyses. We will show how to set up the TopMed alignment workflow provided by the TopMed IRC, as well as how to find the TopMed variant color workflow on the platform, also from the TopMed IRC. We will also show how to set up the GTEx RNA-seq workflow from the Broad and view the results of a previously completed analysis. Before watching this demo video, we encourage you to watch the Team Xenon search demo, which explains how workspaces are set up and how to search the hosted TopMed and GTEx datasets on the platform. This demo will begin from the login page, where users have two options for signing up and logging in to use the platform. Users who want to access controlled data on the platform can log in using their external credentials like ERA Commons, NIH CIT, or Google. The FAIR4Cures platform will use the Fence API to check with the supported identity providers whether the user has dbGaP approvals for any of the controlled datasets hosted on the platform. Users who do not have access to controlled data can log in with their email address. This will allow them to work on the platform, but access only open data and work with their own private data. User Allison Leaf has dbGaP approval to use the control data, but for the sake of this demo, she will log in on the right panel. However, in the future, she would log in on the left panel with her external credentials. Data and analyses are organized into workspaces called projects on the FAIR4Cures platform. Several of the projects are marked as controlled, meaning that a user with appropriate data access approvals can add controlled data from the hosted datasets to these projects, and then use those data files in analyses. Projects that are not marked as controlled cannot contain controlled data. User Allison Leaf wants to run two analyses on the platform, one with the TopMed alignment workflow developed by the TopMed IRC, and the other with the GTEx RNA-seq pipeline developed by the Broad. Both of these workflows are hosted on the FAIR4Cures platform and can be found in the public apps gallery, along with hundreds of the most commonly used open source and commercial bioinformatics tools and workflows. These workflows are curated by the Seven Bridges bioinformatics staff and can be used right out of the box or customized. All the tools and workflows are described in the Common Workflow Language, CWL. CWL is an open standard for describing bioinformatics tools, which has a human-readable description for all of the tools' requirements, resources, and parameters, as well as all the instructions needed to exactly replicate the analysis. Before user Allison Leaf searches for the TopMed alignment workflow to get started with setting up her analysis, let's look at a commonly used RNA-seq tool. So we'll see that several options pop up, and we can see that workflows have this W and tools have the T. So taking a closer look at the RNA-seq alignment star 2.5.4b CWL 1.0, you can see that there's a description, common use cases, common issues to help users avoid problems, changes introduced by Seven Bridges, and performance benchmarking information to help users get estimates about how long the workflow will take to run and the cost depending on the cloud instance. There's also a visualization of the workflow. The tools are shown in teal, the input nodes off to the left and the output nodes off to the right. And finally, there's information about the types of inputs that are required for this workflow to run. So there's a note here about whether or not the input is required, the app settings, and the output files that will result. So now user Allison Leaf wants to run the TopMed alignment workflow. So she's going to go back and search TopMed. And she'll find both the TopMed alignment workflow and the TopMed variant calling pipeline. Descriptions of both of these workflows will be added in the future, as well as the type of information just seen with the RNA-seq star workflow. For now, the workflow lists the inputs, app settings, and outputs. So taking a closer look at the inputs, we'll see that we're going to need our input cram files for this to run, as well as BWA index and a reference for output cram compressing. And the other two inputs are optional. The TopMed alignment pipeline was used to harmonize through remapping a variety of TopMed studies. The variant calling pipeline is the TopMed Freeze 3 version. Both of these workflows are in CWL, like the rest of the workflows on the Fear for Cures platform. They can also be found in DocStore. In addition, the workflows are also available in DocStore in the workflow description language WDL, provided by Team Calcium. To set up a task within the project, the user needs to copy both the app and the file inputs to a project. There are two ways to copy the apps to a project. The user can copy the app directly from the public apps gallery by going here, clicking copy, and selecting the project to copy it to. Or the user can go back to the dashboard and select a project to use or create a new project. So we'll create a new project and mark that it's going to contain controlled data. Click Create. Now the user goes to Apps, Add App, and search TopMed to find the alignment workflow and then copy that workflow to the project. And now you can see that the TopMed alignment workflow is within the project. The next step is to add the files. So we already reviewed which inputs are needed for this analysis, including both the reference files and the input cram files. To add files, Alison Leaf will click Add Files. And first she'll search for the reference files in the public reference files. The reference files actually have tags associated with them that say TopMed. So she'll go to the tags, type in TopMed, and find the 3 reference files and copy them to the project. To find the TopMed cram input files, you should go to the data browser, select TopMed, explore selected, and she's looking specifically for cram files from people ages 50 to 60. So she's going to set up a query starting with the subject entity and add the age property, 50 to 60, add property, refresh, and then the subject will have a file, and here we'll look for data format property and select cram and click refresh. So now we can see she's found a list of 33 files that meet those criteria. And the files are all listed here below with the red closed lock symbol, meaning that it's a controlled file. So it's good that she's working within a controlled project. So now she can copy these files to the project she set up. She can add some tags to help her find them later within the project and copy them to the project. So now she wants to set up the task. So from within the project, she'll go back to the app. Here's the alignment workflow and click Run. And here she's going to be prompted to set all the input files for the analysis. She wants to run 4 of the identified TopMed cram files through the alignment workflow, so she can actually set up batching. So she'll turn batching on. Batching allows a user to simultaneously kick off hundreds of tasks with just a few clicks, instead of setting up a separate task for each individual input cram file. Batching can be done based on the sample metadata. In this case, we're going to batch by file. First, we'll add the BWA index. Now the input cram files, I'm going to add 4 of them. And we'll change this to batch by file. So each file will get its own task. And then we need to add the reference for output cram compressing. So now we've added all of our needed inputs, and we can hit run. And this will queue up the 4 tasks. Since this task is going to take a couple hours to run, we'll show the results of a previously completed task at the end of the demo. Now the user is going to set up a task using the GTEx RNA-seq workflow. So let's first look at the GTEx workflow in the Public Apps Gallery to learn more about the inputs that are required. So we're going to need several reference FASTAs in addition to the CRAM files. So she's going to go back now to the dashboard and create a new project. Mark that it's going to contain controlled data. And now she wants to add the files to the project. She can just go straight to the data browser, browse the files, and she's going to search for subjects between the ages of 30 and 50 who are female. So she'll choose the subject entity, add property, look for age. We'll check 30 to 39 and 40 to 49. Add property, refresh, and now we need to add the gender property, female, and refresh. And then these, she's looking for expression data from brain tissue. So here we will select the sample entity, and we will choose the property histological type so that she can see all of the tissues that were sampled and find brain. Click Add Property, refresh, and finally the analyte type, RNA. Refresh, and then she wants to find files specifically, so she'll add that entity as well. And now you can see she's found 15 files that meet these filters. They're listed here. So now she's going to copy the files to the project. She can add tags. And copy those files to the project. So now the input RNA files are in the project, but she still needs to add her reference files. So we'll go to the project, files, and add files. And we're going to search the public reference files, and these public reference files that we need have GTEx tags to make them easy to find. So we'll add the FASTA sequence and the GTF to the project. So now the next step is to add the app. So we'll go to the apps page, add app, and she'll search for the GTEx RNA-seq pipeline here and copy it to the project. So now the app has been copied to the project, and she can set up the task once again by clicking Run. She's going to do batching, so she'll turn that on, and she's prompted to select her CRAM files. So she'll choose 6, and she'll batch by the file. For the annotation file, she'll select this GTF file. And now she's prompted to add all of the FASTA files. So now she's added all of the required inputs. She can click Run. This is going to queue up 6 tasks, 1 for each of the files. Once again, this task is going to take some time to run. So let's look at the results of a previously completed task running the GTEx RNA-seq workflow. So this was also run as a batch task. It was run by Allison Leaf. You can see the cost. You can see that there were 4 individual tasks run. So we'll look at one of them. You can see that the users can get information about all of the inputs used, the app settings, and access the output files. Importantly, everything is documented, including the app version, the execution time, the user who ran the task. Tracking of data provenance is a fully integrated part of the platform and makes it easy to do reproducible analysis. This way, if someone leaves your organization who is running analyses on the platform, you can still access all this information within the project. And each task remains indefinitely on the platform, so you can always revisit the information. The user can also view the stats and logs to see how tools ran over time. Finally, if a task failed, she could click Get Support and get in touch with the 7 Bridges support staff to help troubleshoot the task. And this is the end of the Team Xenon workflow execution demo.